Okay, factor completely. Now I'm not necessarily going to do all of these. We'll do like a few, right? And then the answers are or will be loaded up in there so that you can check over your stuff. Okay, what's the first thing you do? Something like this. Factor out a common factor, right? Which is what? Negative 2x squared is the common factor. Right? And then what does that leave us with? What goes here? X squared. Then what? Minus 10x. And then plus 24. How many terms do we need inside the brackets? 3, right? As many terms as there were originally, right? Otherwise, when we expand the bracket, we can't get that. Now, if I only have 2 terms in the bracket, then I'm only going to get 2 terms if I expand. So checking this, just do a quick check. Just go, I'm going to get minus 2x to the 4th plus 20x cubed minus 48x squared, right? So that's your first step. Then just do a quick check. And then what happens? Well, we get this negative 2x squared. Does this factor? And what is it?
X minus 6 and x minus 4.
Right, x minus 6 and x minus 4. Okay. So, second one you can do, right? See answers. Okay, see answers afterwards, not before. 256, a to the 4th minus 81. What is this? What do we call this thing? Difference of squares. So, okay, first, any common factor? No. Okay, so difference of squares. What's the first? 256 have a square root? 16. Okay, so it's 6. So what's the square root of 256 a to the 4th? 16a squared plus 9 and
A squared minus 1.
16a squared minus 9. Now I always lead with the plus and then the minus. Why? Nice. And also, what's this? Another difference of squares, right? So I know this can't factor, right? Sum of squares, yeah, you're done, right? But, so that's why I always lead with the sum and then the difference, right? So we get 3a, oops, 3 and a 4, but not in that order. So 4a plus 3 and 4a minus 3. Okay, should we do the next one? Ah, okay. You want to do the next one? Should we do the next one? Why not? Is there a common factor indeed? And what is it? 4x. So 4x. What else is it?
X minus 3.
So it's a 4x and an x minus 3, right? And then what does that leave? 25x squared. Okay, that takes care of that. Minus 9. And what's special about 25x squared minus 9? Another difference of squares. Okay. If at any point you have any questions, please ask. Next one, sum of cubes. Can we factor a sum of cubes? What's the likely answer? Should be more. We can factor a sum of cubes, can't we? Let's try. So it's likely, if it's a sum, if I'm going to cube something, then probably I need the cube root of that. And the cube root of that. Right? That kind of makes sense. Okay? I mean, let's try it. Okay, so now if I want to get 125m cubed, what am I going to need here? 25m squared, right? And if I want to end up with an 8 at the end, then what am I going to need at the end of this thing? Plus 4. Okay, so let's take a look at this. I'm going to get 125m cubed, and I'm going to get the plus 8. That's cool. But I'm also going to get a 20m, right? So I'm going to get rid of a 20m. Now I could do that if I throw minus 10m in here. Okay, because then I'll get minus 20m. All right, so what happens if I expand this? 125m cubed minus 50m. Oh, look, I got a plus 50m here, right? So there you go. Now, it's going a little bit out of order, right? But 125m cubed minus 50m plus 20m plus 50m squared, right? We got the minus 50m squared, got the plus 50m squared. So it's handier if you sort of do the multiplication a little bit out of order, right? But you say, all right, 125m cubed, I got a minus 50m squared, but there's a plus 50m squared, so they're going. Now I've got a plus 20m and then a minus 20m, and then I got a plus 8. Can we factor a different or sum of cubes? Well, the answer now is yes. Okay, does 25m squared minus 10m plus 4 factor? Probably not. Okay, 27x to the 6 minus 1. What could we call this? A difference of, it's got a 6, but it's really cubed, right? I mean, what's being cubed is an x squared that's being cubed, right? Okay, so let's try the same deal, right? We're going to take the cube root of 20. Basically, we need something that's got a cube root, right? Okay, so we're going to take the cube root of that. That's 3x squared. A cube root of 1 is just 1. Now, do you think I should write 3x squared plus 1 or 3x squared minus 1? Let's try minus 1. I mean, we did plus here. That seemed to work, so maybe a minus will work here. Okay, what's going to give me a 27x to the 6th if I multiply by that 3x squared? 9x to the 4. And let's skip to the end. What's going to give me a minus 1? Plus 1. Okay, now what extra stuff am I going to have that I want to get rid of? So I'm going to have a 3x squared, right? So I'm going to need a minus 3x squared. So let's try throwing that in there. Okay, so here, see, I'm going to get a 3x squared, but then this, oops, so I better put a plus on that, right? So I'm going to get a 3x squared, this will give me a minus 3x squared. Okay, yeah, let's check, does that work? 27x to the 6th, so now I've got plus 9x to the 4th, minus 9x to the 4th. Then I've got a plus 3x squared, minus 3x squared, and then I've got a minus 8. So we can factor sum and difference of cubes. Right? You can actually kind of memorize how to do it, but I forget, so I just do it. So the only thing, here's what I remember, right? Cube root of this, and it's the sign that goes with it, right? Once you've done that, it's kind of easy to write it down, right? Just the way we did, right? Like, what's going to give us this 4? Okay, but now I'm going to get a plus 20m. All right, let's get rid of it. Let's make this so it's a minus 20. Boom, done. And then check it, right? What's the most important step in factoring? Checking, okay? Because if you get it wrong, and in calculus where, you know, things go on for a couple of pages, and you factored wrong at the beginning, it's just, you know, and you're carrying that all the way down. It's horrible. And it just ends up messy. Fractions. Fractions. Wow. Okay, is there a common factor in G? Oh, by the way, to do calculus, you need good algebra skills, right? Like factoring. Okay, is there a common factor? What goes into 6 and 10 and 6x and 10x squared? And 2x. 2x. And what else is common? X plus 2 to the half. Okay, that wasn't so bad. Okay, so how do I get that 6x times x plus 2 to the half? Hint.
How did you get a half? Because we have one that has 3 over 2 and then the
Oh my God, you can
Yeah.
see stuff that I can't. All right. Good. Great. I can't even see that, right? So we have a 3 halves and we have a 1 half. So if I want to take common factor, do I take the larger power or the smaller power? Smaller power. The smaller power is the half, right? Okay, so that's why the x plus 2 to the half. So you're saying this is the 3, right? Okay, good. Okay, so 2x times what gives me 6x? 3. X plus 2 to the power of a half times what is going to give me x plus 2 to the power of 3 halves? So I'm going to need an x plus 2, right? What goes up here? So when you divide powers, what do you do with the exponents? Minus them. So what do we got? 3 halves minus 1 half is just 1. So it's 3 times x plus 2. Okay. Yeah, the second part of this should be pretty easy then, right? So plus, okay, I got 2x, I want 10x squared, so plus 5x, right? Just 5x, because we've already got the x plus 2 to the half. Is that it? Stop there, good enough? Not really. These brackets will simplify, right? So let's carry the common factor. Okay, so remember, it's the lower power. And then remember, when you are dividing, because really what I'm doing is taking that x plus 2 to the 3 halves and dividing it, right? Because I'm saying, what do I multiply x plus 2 to the half by to get x plus 2 to the 3 halves? Well, you change it around. So it's x plus 2 to the 3 halves divided by x plus 2 to the half. And don't go through all that mental stuff. Just subtract the exponent. Okay, so 3 halves minus 1 half is 1. And then this is 3x plus 6 plus 5x. Okay, and there is your factored form.
Should you factor out a 2 from that 8x plus 6?
Well, you're right. We could take a 2 out of there. So there's not your fully factored form. There's your almost factored form. So it's going to be a 4x and an x plus 2 to the half. And then dividing this, we'll get 4x plus 3. Actually, hang on. I wrote that kind of ugly. 1 half. Okay, so there you go. So you can factor out fractional exponents, right? You just got to remember to do a little, you take the lower power and then you subtract, right? And you'll get the.
for the x plus 2.
What, here? No, the x plus 2 to the half times x plus 2, that's a 1, which is 2 halves. 1 half plus 1, or 2 halves is 3 halves, which gives me that 3 halves. Okay? So when I expand this, right, I mean, starting here, you've got 6x, and you got x plus 2, that's a 1. 1 plus a half is 3 halves. So you got your 3 halves. Plus 10x squared, and then x plus 2 to the half. Okay? You're going to have to work with this a bit, right, because it's new. As is factoring negative exponents. So next one is factoring negative exponents, right? These negative exponents I want to factor. Okay, so again, we're looking for common factors. So let's start with the 5 and the 10. What's the common factor between the 5 and the 10? 5, right? Okay, so we're looking here, we're just saying, all right, you got 5. Okay, now both of them have an x minus 4. Got negative 2 and negative 1. Which one is lower? X minus 2, or sorry, negative 2, right? So x minus 4 to the negative 2. Then I got a 3x minus 7 to the 5th and the 4th, so which is the common factor? To the power of 4. Then we got 3x minus 7 to the 4th. Okay, that's the common factor, right? Now we're going to put down a set of brackets and say, okay, so I got the 5 already. I need -2. I've got that, and I got a 5th and a 4th. So what goes in here?
Plus 2.
Hang on, we're doing the first term first. Okay, so if I multiply this by this, I'm going to get this. Yes? Okay, you have to work with this a bit, right? I mean, it's kind of formal, right? But there's examples for you. Anything we don't do in class, so I leave blank there, and there's examples for you to do as well, right? Like questions for you to do as well. Okay, so now plus, okay, what? Now you bring in the 2. Plus 2 x. Okay, I got an x minus 4 to the -2, but I want it to be x minus 4 to the -1. So what goes here? So what do I multiply x minus 4 to the -2 by in order to get x minus 4 to the -1? By x minus 4 to the 1, right? Just x minus 4. Okay, so think about that for a moment, right? Look at that and just say, okay, hang on, let me figure this out. So if I just forget everything else. If I multiply this by this, what do I do with the exponents? Add them. What's the exponent on this? 1. Right, it doesn't there, but it's a 1. What's -2 plus 1? -1. Okay, that's what I want. Right? You'll get the hang of it. Little practice. We do a little practice. Okay, now what do we got to do? We got to clean this up, right? So common factor is the common factor. You can do a lot of stuff in this class where you're just copying down the first part of the line, and it's the same as it has been for 6 lines above, and I really wish I didn't have to, but you do. Okay, so you do have to show it, right? I mean, just don't leave it out because it's repetitive. Okay, so what do we got? 3x minus 7 plus 2x squared minus 8x. Okay, so again, the common part. And what do we got? 2x squared plus, no, minus. Is that a factor? Probably not, but you might want to examine it a little bit. I don't think so, right? You get like a 14 or a 7. Well, wait. Could get a 7 and does factor, eh? Okay. Then we should factor. Okay, so what is it? Factor 2. Square plus 2 minus 1. Okay, check things over, right? Even at every step, right? I mean, when you do this here, you might want to just look at it and just say, do I get a, yeah, I get a 5th. And yeah, that's going to give me a -1. Okay, because that's what it looks like. There's lots of this. Okay, good. Ready to move on? Remember, this will be saved, right? So or the answers they're up. Well, they will be up. Simplify each rational expression. Also state the non-permissible values. Okay, well, that's easy, right? I mean, you've been through 20 and 30, and okay. So why don't you? I'm going to pause this, and you can do that. Figure out how to pause this. Okay, so factor numerator, factor denominator, state non-permissible values. So -5, and what's the other one? 3/2. Okay. Yeah, there we go, right? Next one. Ah, it's got to be easy. Do you stuff like this in 30-1? Oh no. Okay, so what should we do? That's not so easy. What should we do? First step. First, do no harm. Let's have a hypothetical. What should we do?
Do not allow a human being to harm.
That's true. Is that the first law? I think it's the first law. We should subtract. We should simplify the numerator so it's a single fraction, right? Single expression. Right now it's a minus, right? So we need. Right now we're just going to work with the numerator. We're going to find a common denominator for the numerator and work that. So okay. Common denominator is going to be one of these and one of these, right? You need an x plus 1, h minus 1, you need an x minus 1. So the 3, this guy, all right, so hang on. Let's do this. Let's list this. Okay, so that's how I'm going to work the numerator, right? And then we say, well, you know, and then you got to divide that by h. So, you know, for right now, let's just go times 1 over h. Right, that gets rid of the complex fraction. A complex fraction is like a fraction over a fraction. Okay, so now it's less complex. So this needs an x minus 1, and this needs an x plus h minus 1. Okay, so see if you agree with that. You see yourself doing something like that? Yeah, I'm not sure. Okay, and then we just simplify away. So what do we got? Let's just clear up the top here. So 3x minus 3 minus 3x minus 3h plus 3 over x plus h minus 1 times x minus 1 times 1 over h. Okay, so 3x minus 3 plus 3 ultimately comes down to that whole thing simplifies to negative 3h over x plus h minus 1 . So ultimately, what do we got up top? Okay, good, bad, indifferent. Oh, that was easy. Oh, what am I in for? Oh. Okay, just practice, right? It's just, you just need some practice on these. You'll see a bunch of them. You've got a model for how to work it now, right? So you say, okay, if I see that, I know that I should split up and forget the h on the bottom. Let's just multiply by 1 over h. Okay, now it's a little bit simpler. Not simple, but it's simpler. Okay, good. I can move on. I should stay. Function notation. Oh, you know that stuff, right? Determine f of 10 if f of x is equal to 3. So what do we do? Okay, wait. Do you have the same thing? Am I missing something?
Don't have any of this.
What? Really?
It's question 3, function notation, that's blank.
Oh, okay. Write this down. How did that happen? Check the back of the other page.
No,
It didn't go there.
It went off on page like it does there, so it just got completely erased.
That's just weird. Like, I mean, it should be right up there.
Tables.
I don't know, man. I don't control it. Yeah, it's a different one. Oh, we'll get there. Okay, write this down. Determine f of 10 if, so what do we do? Everywhere we see, yeah, everywhere we see an x, we're going to replace it with a 10, right? So we could say f of 10. What does determine mean? Show your work. Thank you. I was going to say, what? You made it through like 3 years of math at Wise without anybody telling you determine means show your work. Okay, now it's not this easy, right? Now what? Yeah, well, the root 8 becomes 2 root 2, right? You must rationalize those denominators. Or not, depending on the situation. Right, but generally we like things with rationalized. So you got to simplify the entire radical. Root 8 is 2 root 2. The 2 goes into the 30. And I don't want to leave this with the root on the bottom right, so I need a rational. Okay, B. Determine f of x plus h minus f of x over h if f of x equals 2x squared plus 3x plus 8. So what do we do? Replace. So replace what? So 2 bracket what?
Plus H.
X plus h. Plus 3 times
X plus H.
x plus h. Plus 8 minus, I'm going to throw a set of brackets in there, right? Because I need to remember that I'm subtracting that expression, which is going to be flipping signs. And I want, okay, so what goes in here? 2. So this is f of x plus h, right? This is this. This. Minus what? All right, what's f of x? It's written. Okay, I'm just going to write it down. Okay, so we have f of x plus h. Let's put brackets around that one too. That's big piece. Okay, let's separate it out, right? Let's separate the first term, right? The f of x plus h, that's in that first set of square brackets. Minus f of x. It's just a straight copy, right? I mean, it's written right there, and you just wrote it, and I have it printed, but you didn't. Don't know how that happened. Okay, now what? Expand it. Yay. Now what? Keep going. HX or XH, that's what doesn't matter. Okay, now if you wanted to, you could have gone from here to here, right? From this to this, you don't need that. But yeah, I mean, you need to square that, but you could also, at the same time you're squaring it, multiply it by 2 and get straight there. Okay. So that's okay, right? It's your comfort with the level of detail that you need to show or want to show. Okay. But going from skipping this line, not bad. Right? Not a bad thing. Okay, let's combine all this, right? So what do you got? 2x squared. You know, I'm going to go for, I changed my mind. I want to go xh instead of hx. Minus 2h squared plus 3x plus 3h plus 8 minus 2x squared minus 3x minus 8 over h. Okay, now switching to a different color. I got 2x squared and minus 2x squared. I got a plus 8 and a minus 8. I got a plus 3x and a minus 3x. Okay, so those are all just going to take each other out. So the next line, 4xh minus 2h squared plus 3h over h. Okay, so we can factor in h out of there, and that all. And we're ultimately left with 4x plus 2h, no, sorry, minus 2h plus 3. Okay, wait.
It should be a minus.
This should be a plus, right?
Yeah,
Plus, 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 plus. Hey, they all change without any erasing. Thank you, Peter. That's your guys' job, right? Make sure that this answer is correct. Okay, what's on the next page? You have this, right?
Yeah.
Okay. All right, rationalize the numerator slash denominator. It's amazing how rationalizing the numerator, right? Haven't done that before. But it's a calculus thing. Sometimes it helps us to rationalize the numerator. So if I wanted to rationalize the numerator, what would I multiply by? Two terms. I'm going to have same two terms, only instead of a minus, I'm going to have plus, right? I'm setting up a difference of squares, so I end up squaring this thing, right? When I square square root disappears. Now, whatever we do to the numerator, we must do to the denominator. Okay, so remember, we're rationalizing the numerator. We will end up with a radical in the denominator, and that's okay. That was the point of what we're doing. What's root x plus 4 times root x plus 4? X plus 4, right? Just what do? You square what's root 9 times root 9? 9. Okay? So it's x plus 4. And then we got what? Difference of squares, so minus 2 times plus 2, minus 4. Okay, and then we've got x times root x plus 4 plus 2, right? Which, and that's an expression, so it's in brackets, right? It's x times that expression. Especially considering that plus 4 minus 4 is 0. And these guys cancel. And there there's your expression with a rationalized numerator. Okay, rationalized numerator. Okay, it's going to come in handy. Next one, rationalizing the denominator. You want to give that a shot? Yeah, you do. Let me try. I'm just going to fill in a little bit here. Okay, so the thing you're going to multiply by is the conjugate of this, which is square root x squared minus 4 minus square root 4x plus 1, right? Top and bottom. Multiply that out, multiply this out. This eventually comes down. This is going to factor. And one of the factors will be x plus 1, right? So they're going to cancel off. And the other one is x minus 5. You check the x squared minus plus. Yeah, okay, good. Cross that off, and here we go. So it's the square root of x squared minus 4 minus okay, now there's something minorly wrong there. What is it? Yep. This one?
Yeah.
Yeah. It's not under the radical sign. It's not bracket, but it's not under the radical sign, right? So when you're writing radical signs, watch, right? Just make sure they're long enough to cover everything that you want covered, right? Otherwise, that becomes a totally different expression, right? It's then minus the root of 4x plus 1, not the root of the whole thing. Okay? Good? Yeah? How'd you do? Practice. Okay, not just practice, right? Practice by itself. So, oh, you did 4 hours of homework last night and stuff. No. Here's the key. It's called fix it focused practice, right? So here's what you do. Do a question, check the answer. If it's wrong, fix it, right? You got to figure out, what did I do wrong? Now, your first step should be look through your work and try and figure out what you did wrong. You know, and then your last step is, okay, go to the answer book and look through and then figure out what you did wrong. Okay, but you have to fix it. If you just sit there and do 10 questions in a row, all wrong, then you are very good at doing that particular type of question wrong, and will be for quite a long time. Okay, so you need to fix it. It doesn't matter what you're doing, right? Math, English, whatever. Fix it, focus, practice, right? You don't do a second draft of the English essay so it comes out worse than the first. You go back and you fix things.
Just a question for the expression. Since it's a minus 4, you can't make it x plus 2 or x minus 2.
You don't want to. The root of it'd be the root of x plus 2 x minus 2. It doesn't really get me anywhere, right? Yeah. So no, as a single expression. Okay. Fix it, focus, practice. Right. Everything you do. I don't care what. It doesn't matter what you do. Determine the equation of is you got the expression? Okay, good. Determine the equation of a line with an x-intercept of -6 and is perpendicular. Really? Is yours worded the same? I think it should be and that is perpendicular, but yeah. To the line passing, I should change that, right? Change that. Huh. Perpendicular line passing through, express the answer in general form and in slope y-intercept form. Seriously? Isn't this like math 20 or something? Yeah, is it? Yeah, it might be, right? Okay, so 5 is left. You see this in textbooks often. The following is left as an exercise for the reader, right? Well, you will see this, and like, yeah, it just means they couldn't do it, so well, you do it. It's too hard enough. Sketch the graph of y equals 2x times x minus 5 squared times 2x plus 7 cubed. Label all intercepts. Okay, you should be able to do this, right? So why don't you give it a try? Okay, so we know what this looks like, right? I mean, start off by figuring out what are the zeros, right? The intercepts, right? Yeah. Intercept. I think the y-intercept occurs when x is 0, so I think that's right. Start, that's started. What degree is this thing? 6th degree. And the leading coefficient is? So it opens up, up, right? I don't know, how did you guys describe end behavior? Yeah?
Hold on, I'm just saying that.
Oh, yeah, just up. Up and up. I mean, on 30-2, it says only goes from quadrant 2 to quadrant 1. Right, so like it starts in quadrant 2 and it ends in quadrant 1. Yeah, which means that it has to be opening up, right? So it does that, and what do we know about this guy? The multiplicity 3. Yeah, okay. So then what does it look like?
It's like a curve.
Yeah, it curves through, right? Not straight through. Multiplicity 1 goes straight through, right? Okay, so we're going to come from up here. I can't see what I'm drawing. Okay, so we're coming from above, we're crossing through the -7/2, which is root of multiplicity 3, telling us that there is a change. Did you guys call that anything in particular? No, just a curvy thing. It's like a snake. Okay, then passing straight through 0, right, because that's the root of multiplicity 1, so that's straight through, and then kind of bouncing off the 5, right, because it's a degree, it's an even degree. If you get a really large even degree, it just flattens out a little bit more when it does that, right? Like it just, stays flatter longer. Okay. That cool? Yeah, pretty good. Except for you need to do number 5 on your own. Is there more? Determine the domain of each function. Okay, so what do we do to determine the domain? What do I need 9 minus x squared to be? Yeah, greater than or equal to 0, right? So, how do we solve that? Well, you could do this. What does 9 minus x squared look like? Okay, when is 9 minus x squared greater than or equal to 0? When x is between -3 and 3. Oh, wait, that's ugly notation, isn't it? How should we write that? Let's use brackets. So what kind of bracket do I start off with?
Square one.
Square one. And then what? Way better, isn't it? There's domain, setup, blah. Okay. 304x squared plus 1. What's the domain? Yeah, you're right. It never can it? Because x squared is always positive. 4x squared is therefore always positive and at the least 0. Then you're adding 1. So it's a domain. Real numbers. How would we say that in bracket notation? can't never get there, right? So you can't put a square bracket. Okay, 5 over the root of x squared minus 1. So square roots are always positive. That doesn't really do anything. Who cares if it's over a negative? So what does x squared minus 1 have to not be? What can't we have in the denominator? 0. What makes x squared minus 1 0? 1 or negative 1. Okay, so what do we got? Let's try this. So you can be this, this. How's that? That look good? Okay.
Shouldn't it include it though? Because -1 squared minus 1 would equal to 0, and you can take a root of 0, can't you?
Which is?
0.
And 5 divided by 0 is?
Yeah.
That's why there's so many brackets there. Because we're not including it, right? But it could be anything less than -1. It could be anything between, strictly between, right? -1 and 1, and anything greater than 1. Yeah, I mean, that might be better stated. You could just say x is less than -1, or x is greater than 1. Well, you still have to say all three, don't you, in some way? Now, wait a sec. Wait. There's a problem. X squared minus 1 could be 0, right? Yeah. So let's get rid of this. You can't have it in here. Yeah, you can't. You know, if you look at the graph of x squared minus 1, it drops down, right? It's negative. It looks like this. Okay, so that's out because we can't take the square root of a negative. Right, so it can't be 0, it can't be negative. So you could say that in other words. So x is less than -1 or x is greater than 1, strictly. Okay. Sketch the graph of y equals x minus 3 for x is greater than 3 and the graph of y equals -x plus 3 for x is less than or equal to 3 on the grid shown. Examine the graph and write a single equation for the entire graph. Okay, so x is greater than 3. So what's y equals x minus 3 when x is 3? 0, right? Okay. So when x is 3, we got a 0. But that's not included, right? So you're going to need an open circle there, right? Because we want greater than. Okay, so what's 4 minus 3? 5 minus 3, 6 minus 3. Okay, so there's that, right? And then we have the graph of -x plus 3 for x is less than or equal to. So x plus, so that's going to be a 0 here. So now it's included. And then what do we got? So less than, so negative. So when x is 2, that's -2 plus 3. -2 plus 3 is 1. And then it's -1 plus 3, which is 2. That's -3. And then it's. And what's a single equation that describes this?
Y is equal to absolute value of x minus 3.
Correct. Okay, is that it? Done. Ooh, okay, now what? You have questions, right? I mean, you have exercises to do, and a couple of ones that I left out. But hey, look at all the time. I don't left a lot. But you could stay for wise time. What do we have? 11:41. Yeah. Oops. Let's do that.